Hello students, today we will perform an experiment that is determination of Stefan Boltzmann constant. The actual value of Stefan Boltzmann constant is 5.5 into 10 raised to power minus 8. But how can you determine it with the help of experiment? So the apparatus is provided in heat transfer lab. We will perform the experiment and find out this value of Stefan Boltzmann constant. So before performing the experiment, we will go through the schematic diagram of the apparatus. So various components of the apparatus is drawn on the paper. So on the top there is a geyser which is controlled with a controlled unit. Controlled unit means there is a thermostat. Settings are available with the supply given to the geyser so that we can set a desired temperature in the geyser. So we will work in the geyser from 50 degrees centigrade to 100 degrees centigrade, let us say. So we will set the temperature in control unit. The heater will automatically off at that particular temperature. Two valves are provided, valve 1 and valve 2. When we heat the water in the geyser, we will close the valve 1 and we will open the valve 2 so that any water which is remaining in the cavity in between the outer envelope and the inner spherical surface. So this is the part where the water have to fill. So we will drain any available water in this cavity from valve 2 by opening it. When whole of the water is drained, we will close it. So the arrangement for this envelope is given over here. Outermost envelope, inner spherical, that is basically hollow, and at the center of the sphere a disc is available. Two sensors are provided, one is on the inner sphere and second one on the disc. So there is no physical contact in between the disc and this inner sphere. So when the inner sphere is heated with the help of hot water, the heat will radiate to the disc and rise the temperature of the disc. We have to record the rise in the temperature of the disc with respect to the time. So this is the schematic diagram and whole over working of the apparatus. Now we will move to the apparatus and perform the experiment, by which we can find out the Stefan Boltzmann constant value. On the top of this apparatus there is a geyser provided, and the temperature in which we will work out will be taken arbitrarily in between 50 degrees centigrade to 200 degrees centigrade. Thermostat is available on this side, and this will set the temperature of the geyser so that when the water temperature will reach in the geyser at that particular level, the heater will automatically cut off. When the temperature on the geyser reaches up to the desired limit, first of all we will ensure this valve is closed and we will open this valve so that the remaining water in this jacket will drain out, and when all the water will drain out, we will close this valve and open the hot water supply in the jacket, and we will wait for the insurance provided by this port. When the water comes out from this port, it will indicate yes, the cavity is completely filled. So we will wait up to
Okay.
So you can see that the water is coming out from this port. It means this is the indication the water jacket is completely filled. Now, two sensors are provided on the inner spherical shell and the second one is provided on the disc. We will check the temperature initially. So the temperature is 70 degree for the inner sphere and near about 24 degree for the disc. So this is the initial temperature. Now we will take the readings of the disc temperature after equal intervals of time, say 1 minute or 2 minutes. So here are the readings of Stefan Boltzmann constant experiment. The experiment start at 12:57. The temperature of the enclosure is 68 degree at that time, and the temperature of the disk is 23. After equal intervals, the temperature of the disk going on raising, and it will raised to a temperature of 36.2 degree centigrade at 170. So the temperature of the disk increased from 23 degree centigrade to 36.2 degree centigrade in the total time interval of 20 minutes. There is no physical contact between the disk and the enclosure, so we can say that the energy is transferred from the enclosure to the disk via radiation. So next step is calculation. Here is the calculations. This is the standard formula. E is equal to sigma T raised to power 4, which is written in red pen. So sigma value is stated over here, that is 5.5 into 10 raised to power minus 8. This is the standard value, but by applying the heat balance equation, we can find out the value of sigma experimentally. So on the left hand side of the column, this is a standard formula which is used to calculate the heat gained or heat lost by a substance, that is MSDT. M is the mass, S is specific heat. You can check the specific heat of the disk material is given in joule per kilogram Kelvin. dT is the temperature rise of that particular substance or the body. So initial temperature of the disk is 23 and the final is near 36.2. So dT is the difference of these two readings. On the right hand side, it is mentioned about the radiation heat received by the disk. So this is the formulation which will give the value of the radiative heat received by the disk. Sigma is Stefan Boltzmann, which we have to determine. AD is the area of the disk. We know that this value is given. TE, that is the initial temperature of the enclosure, 68 degree centigrade mentioned on the table. TD is the initial temperature of the disk, that is 23 degree centigrade. So heat received will gain the temperature of that particular body. So we will equate these two formulations, and sigma is taken on one side and all other equation is taken on the next side. So you can see initially the value of TE, that is 68. Initially the temperature of the disk is 23. TE means enclosure initial temperature. TDI means disk initial temperature. This is in degree centigrade. After 20 minutes, the temperature of the disk is 36.2, that is the final temperature. So in the denominator there is TE raised to power 4 and TD raised to power 4, that is the initial temperature basically. First of all we will convert it in Kelvin, because the value of K we have put over here, that is 383, that is in Kelvin. So we have to change the temperatures in terms of Kelvin. After doing the calculation, we have find out the value of the Stefan Boltzmann constant is 1.1 into 10 raised to power minus 8, and the actual value is 5.5 into 10 raised to power minus 8. What may be the reason for that? It is near about, we cannot say it is near about same, it is different, but why it is different? So this is the next question.